Hello and welcome to Better Than Art School. This is a mini lecture on color mixing. Okay, so the first thing I want to say about color mixing is that always remember that you can have variations on a single hue. So these are called families of color. This is important because if you have a large painting, say, and you have the same blue throughout the whole painting, it's going to flatten the entire painting. But if you have slightly different blues, maybe it's a little more saturated over here, maybe it's a little darker up here, maybe it's a little lighter over there, maybe it's a little more washed out down here, maybe it's a blue moving towards a blue violet down here, then you're varying it through all three dimensions of color. Suddenly you have this kind of, you see the same theme, but has a slightly different cadence, and they all kind of point to each other, but they morph and change as they move through the painting, and it makes the painting have much more color movement and also have more space in it. Because remember, color is spatial, it's 3D. And if you have all the same color, you're flattening the space, you're collapsing the space. Okay, so back to the intensity lecture, I talked about how the left side of the color wheel is more intense than the right side. So these are, generally speaking, the warm colors. You got the obviously warm colors like yellow, yellow-orange, orange, red-orange, red. Those are all really obviously warm colors. Then you have the cool colors, blue, blue-green, blue-violet. These are obviously cool colors. But then you have these kind of in-between colors, like, well, green is a great example. Is green a warm color? Is it a cool color? Well, if it's a blue-green, it's definitely a cool color. If it's a yellow-green, I don't know. Is it a warm color? It's sort of in between. So within each color, though, you can have warmer and cooler colors. And this is another way to keep your colors moving, is to consider that red, for instance, can have a red that's moving you towards red-violet, or it can have a red that's moving you towards red-orange. And the red-orange is warmer, the warmer pole of red, and the red-violet is the cooler pole on the other side of red. So red-orange is on one side of red, red-violet is on the other side. So you've got cooler version on one side and a warmer version on the other. And all colors are like this, even yellow. You can have kind of a lemony yellow that's starting to feel cool, and you can have a more yellow-orangish color that's starting to feel more warm. Okay, so there's two main kinds of color mixing. There's subtractive, where you subtract out wavelengths of light, like when you put paint down on a paper, or additive color mixing, like a computer screen or a television, where you're adding wavelengths of light to create new colors. So subtractive color mixing, if you're doing paintings, if you're cutting out color paper and gluing it on top of each other, that's all examples of subtractive color mixing. This is a short little video, and these are swatches from Home Depot, and I'm just quickly trying to mix them. Of course, the video is sped up a little bit, but you can get the idea. Now, if you're looking carefully, if you can see what I'm doing there, I put red in the green, I put a little red and a little blue into the yellow, and that's what you do when you color mix. A yellow isn't just yellow. And these kind of tonal colors these swatches that they have, they use a color and they'll take a little bit of its complement and mix it in, and then maybe some white or maybe some black, but it makes a color a more rich experience and it feels more spatial. Okay, so let me just move myself up a little bit. Okay, so if you remember the Roy G. Biv idea, it's red, orange, yellow, green, blue, indigo, violet. And the red is the longest wavelength and violet is the shortest wavelength. So blue paint absorbs all the longer wavelengths and some short wavelengths, and we see the short wavelengths that it reflects. So when you put blue paint on a white sheet of paper, what you're doing is you're absorbing all these other wavelengths of light, and the one that bounces off, our eyes and brains will interpret as blue. So it's actually anti-blue in a way. The paper is actually anti-blue now. You pull in all these other wavelengths, and boom, the one that bounces off is blue. And then yellow, it's the same thing. It's a longer wavelength, and that's what we see when we subtract out the middle and if white light's at all intensity and we subtract out all these other wavelengths of light, and the only one that's left is the yellow one, the one that we encode as yellow, then that's what's happening. So you can think of paint as what subtractive color is doing is you're subtracting, that's why it's called subtractive, you're subtracting wavelengths out of it. And a green piece of paper or a green paint on paper is anti-green, technically speaking. It's pulling in all these other wavelengths, and the one that bounces off, because it can't absorb that, is interpreted by your eyes and brain as green. The human in the world is kind of like a machine for turning a quantity, like a medium wavelength of light, just a photon doing this instead of doing this, into green, into the quality. So it turns a quantity into quality. We see a quality like green. And so that's what's happening when you're color mixing. That's what subtractive color mixing does, is you're subtracting out wavelengths, and then the thing that bounces off and hits your eyes and brain are what's left over that hasn't been subtracted. Now, additive color mixing, of course, is the opposite. And one thing that's kind of interesting in subtractive color mixing, the primaries are red, yellow, blue. Okay, those three colors you can't mix, and they can mix all other colors. But in additive color mixing, it's red, green, blue. That's right, it's called RGB. And basically what adding color does is you take a wavelength of light and you put it over another one, and that adds another color, so you're adding wavelengths instead of subtracting them out. You're not absorbing wavelengths, and so we see blue or whatever. You're adding the wavelengths, so we'll see whatever color you want us to see. Okay, so this is a little additive color mixing I'm going to do for you on Photoshop. So the first thing I do is I look at this hue. This is just, you're moving through the hue dimension of color. Then on here, you're moving through value and saturation, basically. And then, so I selected this color, and I just filled it with that color. Then I took red, okay? And I drew a little box over here, and then I just did red at 20% transparency. Then I did another one at 40% transparency. I did two more boxes, and they get less and less transparent. And what you're seeing is by doing transparent layers, you're getting the colors to mix. Because it's kind of hard to mix with additive color unless you do transparent layers of color like that. Okay, so this is interesting little historical idea for you. Pointillism, where people do little dots of paint, they weren't just trying to make a painting out of dots. That's what you're taught in art history, maybe, that they're just trying to make paintings out of dots. No, they were studying optics, and they're trying to make a television screen. They're trying to make light emanate out of the painting. So if you look at this painting by Seurat up close, it's just RGB, RGB, RGB everywhere. It's just little RGB dots, but it gives you all the colors. You can see purples and blues and all these other colors, but it's just RGB, RGB, RGB all throughout it. And that's what, of course, a television screen or computer screen is doing. If you can peek behind, the TV, this is all you're seeing. You're just seeing red and green and blue at different intensities, and then it gives you all the different colors that you see. So this is the spitting fountains in Chicago. It's Chicago art, and this is a great example because you'll see this face, a realistic person's face, and they're spitting water at you. And then if you can walk up to it without getting water on you, you'll see it's just this on our right here. You'll just see it's these little RGB dots. So again, subtractive color mixing by removing wavelengths of light. Remember, green paper is negative green. It's absorbing all the other colors, and green bounces off and hits your eyes. Additive color is combining wavelengths of light. So you're taking different colored wavelengths and putting them together to make new wavelengths. And then in subtractive color, it's red, yellow, blue, and additive color, it's red, green, blue. Okay, there's a little baby duck, and I'll see you next time.